define things like count infective, things like that, maybe count low at CS, whatever. So these are good things, but be aware that each time you apply one, you say count the number of infected people. Maybe you have three statistics: count susceptible, count infected, count recovered. Does that make sense? Suppose you wanted to display each of those in a graph: the number of infected, recovered, and susceptible. So in the graph, you have 3 lines, and each of them is associated with each of them, with one of them, exactly one of those. Be aware that each call is doing a complete traversal of the population right now. It's not doing one traversal where you say, oh, this one's susceptible, this one's recovered, this one's susceptible, again susceptible, infected, susceptible, recovered in one pass. It's doing actually 3 complete passes. And I have not seen that be a big problem, but you did see a case there. Remember count ill? Do you remember that? Where it actually is an issue it's imposing some non-trivial computational burden. Just be aware that if this becomes a big issue, I would encourage you to use statistics. Statistics in AnyLogic are extremely valuable. I use them all the time, and I do so without regret and with minimal adverse results. But just be aware that if you're going to use them a lot, you're going to be updating a lot, it may be that you want to think about using a profiler or other tool to figure out, are these likely to be an issue, and maybe using a different strategy. Turns out that for those who are more advanced, Java 8 has great tools for doing this sort of thing in single passes through streams. And you can, in a single pass through it, sort things into different bins and stuff like that. And that might be something to think about. You can also use variables to record when someone gets infected and just increment a variable, etc. But the point is that you got to be a little bit wary of that in cases where you're really suffering performance. Do use them. They're really useful. They more than pay themselves back in terms of ease of use, transparency. But just be aware that when you're looking for reasons for your model being slow, that is a possible consideration. I talked about visualization. There's also tuning parameters you can use within each experiment to get it to try to run more quickly. Okay. Right. I think I'll skip this these components. Network construction, we have had models where calculating scale-free networks up front with large populations has imposed quite a long latency. That was with AnyLogic 6, and I was surprised actually, because the Barabazi algorithm isn't inherently, the algorithm it uses isn't inherently that complex, but it may have been resolved in Java, the new release, but in AnyLogic 7. But just be aware that we have had issues with that in the past. The final thing is output of data. And if some of you are considering output to databases, you should be cautious, because within the databases, you will find that that sometimes you put a lot of data there that offers minimal gain. There is a risk that you'll put a lot there, and it has a high cost. It can really slow down the simulation, like by a factor of 2. So if you're going to output to a database, which I would encourage, it's a great mechanism, make it enableable and disableable. So you can disable it when you don't need it, and then when you really are sure what run you want to run, enable it. When it's a run of gravity, of significance, run it. But if you're just doing exploratory work, turn off the recording to the database. Okay? Good. Okay, those were some comments on performance issues. I apologize for the brevity. You will find lectures of me online with greater detail on the performance front.